anyways, hi everyone, my name is Taro Mia. Welcome to TechValley Game Space lesson night. We are doing part 2 of intermediate programming, but I'm going to quickly do a review of intermediate programming 1, just so that everybody is on the same page. Hopefully everyone has all this information in their head, but nonetheless, let's make sure that we have all these things reviewed. Before I go any further, are there anything that I need to cover or that needs to be addressed first before we actually start the lesson? No? Alright, so let's start off with a quick review. Basically, the last set of slides were talking about part 1, basically, was talking about structs. And a way to define, structs are basically this kind of like new variable that allows you to conglomerate a bunch of information by listing out a bunch of member variables, which structs themselves can store, instances of structs can store, and then also a list of functions that we call methods, again, also as stuff that each struct instance stores, and then you can use the call to create a bunch of changes to the member variables going forward. Here's a quick note review on how to use a struct. When you're using a struct, you need to say new, and then the type of that struct itself, so that creates a new type variable. And then similar to using the example here, it has a member variable and then a method named func. You can use that to set the variable to 1 right here, so that we're setting the member variable here to 1, and then we can set the we can call the func function. Access modifier, these are the public and the private that you can replace these with. Access modifiers change the accessibility of variables, functions, structs, properties, classes, and other random stuff. So this is a lot of times you use this in reference to you use access modifiers to adjust whether certain variables are visible within certain contexts, and also to kind of like prevent a lot of accidents from happening. So private is often the most preferred way of declaring member variables for most programmers. Line of reasoning being that if you want to keep track of any changes that are being made on that variable, keeping it private and using a property instead will be a good idea to do so. You just have to rewrite the setter on that property to print out what the changes were, at what line that has happened, so on and so forth. So there's a lot more flexibility behind using properties to replace variables than using variables themselves. Constructors are a customized method of creating a new struct or class. The last time we talked about making a struct, you can see here an example of it. A test equals new A, and then here it's adding in a parameter 20. You can create your own custom constructors pretty quickly just by using the public, and then rather than indicating what the return name is, using the name of that struct immediately along with however many parameters are necessary. Just to let you know, structs themselves, you're not allowed to have constructor that has no parameters in it. Structs automatically create default parameters. We're going to be talking about classes next, which I already spoke about. I already previewed in the beginning, but just to let you know, with classes, you are allowed to define a default constructor, which is, again, any constructors that has no parameters in it whatsoever. Read-only. Read-only is a way of forcing a variable. It can be used in conjunction with access modifiers, but read-only forces a member variable to only be changed within a constructor. Anytime you try to change it elsewhere, such as a line below right here, test.a equals 10, then the code will give you an error, the compiler itself, because A is read-only, and therefore it cannot be changed elsewhere. I should probably clarify with access modifiers that access modifiers changes accessibility outside of the struct itself. So this is outside of the struct's open and close brackets, so that's the reason why this example holds true. And then finally, properties. I've been talking about a bunch about that but basically it's any methods that looks, or a set of methods that look like a member variable itself. Usually it allows either a get or a set sort of functionality. If you define a get, what it expects is to return the type of whatever the property is declared. If you use a set, then there will be a new variable named value that is set to the type of whatever minutes is. And you can use this, I'm using minutes here, you can use minutes simply by using it as if it's just another a member variable. So this is like a really quick and easy way of hiding information. This example right here, seconds is the actual member variable that holds any information whatsoever. And then minutes is a property that sets seconds by converting the number of minutes to actual seconds. And you can see that example being used down here. Pretty simple stuff. All right, so let's talk about intermediate programming. This is literally about what the heck classes can do and so forth. So let's get right to it. Remember, starting with functions and leading into structs, all of these new features we're talking about are really just ways to organize a lot of code. So up to this point, we've been talking about how functions is just a set of variable declarations, lines of variables of declarations, and lines of operations all combined into, a single function that you can call by name. Similarly, structs are ways to group together member variables and functions that uses those variables into a single variable. And classes is almost exactly the same thing, but it has some new extra features that further emphasizes the importance of that. So again, to be absolutely clear, these are actually fundamentally not all that complex. It's just the fact that it's one other method of organizing your code to be more readable as you move forward. Again, also remember that if you already have a struct, you can immediately upgrade it to a class by changing the name struct right here to class. As you can see, this red text changing. So, simple stuff. All right, so let's talk about classes. Last time I gave you a preview of what classes involved. We're going to talk about some extra new awesome stuff covered with chocolate about what classes bring to the table that structs do not. So here, classes actually brings in a lot of really cool features, including inheritance, polymorphism, and abstraction. But that's a whole lot of jargon. So let's actually see. So what I'm going to do here is I'm hopefully going to be able to demonstrate through example using the Unity editor right here to describe. Okay, here's what you need to do. Here's what these features entail and what the benefits are from using these. So let's talk about inheritance. This is, in my personal opinion, the most powerful thing to understand and one of the easiest ones to also understand as well. So let's start off by making a new script. We're going to make a new script called feline, and it's going to have all these variables, the public var, the protected var, and the private var, each with the corresponding access modifier. So let's start with that. We're going to just say create C# script. We're going to name it feline, and we're going to double click on that. That should in turn open. I guess I can just click on the open there. Oh, here it is. Okay, so this is Visual Studio. I don't know why it was acting up, but anyways, here we go. So we're going to take out all of this. We're going to keep the model behavior in there, but we're not going to need any functions for this purposes. Serialized field, for those not in the know, in Unity, if you say serialized fields, then it makes it so that any sort of fields, any sort of variables, that member variables that this mono behavior class has, it'll be listed out right here in the inspector. But anyways, we're going to call it public. I think it was string that we wanted. Yep, public string. We're going to call this public var. And then I'm going to basically copy and paste this. Replace this with protected, which we will go over what the heck that means. I did not actually review that during part 1, but we will go over it here in part 2 as promised. And then finally, the private var. So this is what the code should read like. Public var, protected var, and private var. Good point. Thank you for catching that. Here we go. Is that visible to everyone? All right. So to test this script in Unity, it's really simple. You just go to the untiled right here, right-click on that, create empty. We're going to create that empty, and then we just drag and drop the feline under the inspector. And you notice that this inspector changes based on what I'm clicking under the hierarchy. In this case, I chose game object. I'm going to rename this to feline for the sake of making it easier for me to read. And you might notice that in the inspector, we have a public var, protected var, and a private var. So right here, as I noted earlier, if you put in the serialized field, it'll make all these variables appear. So far, useful stuff. Now, let's make a new script. This one is going to be incredibly minimal, and we're going to just call it cat. So here it is. Cat. We're going to open it. And it has a bunch of really awesome stuff in here, but we're not going to need any of these. We're not going to need even mono behavior for that matter. We're just going to replace mono behavior with feline. There. So notice how minimal this script is. There's nothing in here except for the fact that right here I say colon and then feline. Almost just like the feline right here saying colon mono behavior. But up to this point, I bet like for a lot of people, they haven't really figured out what the heck this whole thing means. This is a quick demonstration of what this actually means. So if I do this, I create a new empty. It's taking a while to compile. Let's create a new empty. I'm going to call that cat. Just to make sure, is the stream going just fine? Yep. So again, you might notice under the inspector, feline has a public variable, protected variable, and private variable. Again, that's because feline script itself has public variable, protected variable, private variable. Cat has none of those variables, and yet if you switch to it, you might notice that it too suddenly got the public variable, protected variable, and private variable strings in it. So what's going on here? What just happened was that when we wrote the code cat, the cat inherited a lot of features from feline. So the quick abstract of this is that, in Darwin's theory of evolution, the children of a species inherits the traits of their parents. For example, giraffes' children will always inherit their parents' long necks. And you see these in basically a lot of these animals. Now, there's a lot more behind Darwin's evolution that I'm not going to go into further details, but computers are perfect. So, we're going to skip the mutation part of things and instead talk about similarly how classes can basically inherit any member variables, properties, and functions from other classes by using what's called extension. So for C#'s case, extension is simply just writing in the class name right here, then colon, then whatever class we want to extend from. That's literally just it. So long as you have this, then it will cat will basically inherit all the member variables, in this case public var, protected var, and private var. So basically these two classes now have almost exactly the same information as each other because cat doesn't actually define anything new within its class. Do note there are exceptions in C#. You cannot extend off of static or sealed classes. I'm not going to go over what those two mean at all in these set of slides. They're a bit advanced material stuff, and I have only so much time for this presentation in this very, very dense topic. So moving on. Generally good practices for how you'll want to use inheritance. So child classes are usually created to add extra definition from the parent class itself. So here's a pretty good example of us generating a bunch of reasonable child classes based off of their parent class. So for example, here the cat and the tiger are good candidates for classes that would extend from a feline class because both of them are felines. Felines and canines are another good class example for extending off of a mammals class, and mammals and reptiles class would extend like an animals class. Generally speaking, what you need to basically remember is the fact that all the child classes that will be extending from the parent will inherit all the member variables and, functions. So you'll have to ask yourself, is it actually worth inheriting these extra information at all? If it's inheriting a bunch of information that the class itself really doesn't need, then you might want to question about splitting that off and splitting the parent class into two parts. One where the parent becomes the child, and then the other thing that you're thinking about, create that as a child. Worth noting, classes in C# can only inherit from one class. In other languages, Java can also only extend from one class as well. And C++ can actually extend from multiple classes. It's highly recommended not to do that. It makes the most sense to only extend off of one class. This is largely because of the question of what happens if two classes that a class inherits from have the same variable names, right? Then there's a conflict and you don't know which ones it's going to invoke with or which one it's going to use. So Java and C# made that like an actual restriction on the compiler itself. So it will not run if you try to extend, if you try to write a class that extends off of two classes. That said, if you go through a bunch of code, you might notice that sometimes you'll see a comma and a couple of other names attached to right after class extension. Those are advanced material stuff. We will go over eventually what those mean, but it's neither here, it's not for the slide purpose only. So unfortunately, I'm not going to be able to explain why they can do that. There is an exception. Just to be clear, though, this rule still applies regardless, including those syntax that I've just talked about. So a quick note about access modifiers. Earlier, I mentioned that you can access modifiers modifies how accessible certain things or where certain variables can be accessed and called. So if I were just to make a function here, private void start. And then I said, I want to be able to change the public variable to a new name within start. Like, it'll let me do that. You might notice that if I were to do that for protected, it'll let me do that as well. So if I were to run this right now, we're looking at cat. On the inspector, you should see that it say public and protected. That's because the start function ran and it allowed me to change the public variable and the protected variable. Again, these are variables inherited from feline. If I were to do the same thing for private variable, here we go. You might notice that Visual Studio is complaining that you shouldn't do that. Yeah, change private variable to 0. No, that's not. Doesn't make sense. It's complaining that we shouldn't do that. If we switch, I did save this, right? If we switch to Unity and then we switch to a console here, it's saying cat feline private variable is inaccessible due to protection level. That is right, because private variables are private and that is not accessible anywhere, even within its children. So public variables and protected variables are accessible from its children. Private variables are not, is the point of this demonstration. So we're going to go over a little bit on why protected is a separate entity entirely, despite the fact that it seems to act so far a lot like public does. But anyways, the other thing that we need to talk about before we go too far into the topic of protected access modifiers is typecasting. Typecasting is directly related to inheritance. So what we're going to do is we're going to create yet again a new script by first getting rid of this private variable thing because we don't want that at all. And then in this new script, also it's complaining I have some new line issues, so let me fix that. There we go. All right, so we're going to, again, start with a new script. We're going to switch back to project and right-click and say, start a new script. And we're going to call this call. I didn't have a good name at the time, so call it is. I'm gonna kind of go a little ahead and start making a game object called call, drag and drop call script in there, open call, reload, and then call has a bunch of things here. What we're gonna do is we're gonna have a serialized field, and then we're gonna have a private feline member variable. We're going to define that. And then, yeah, actually, that's pretty much it. That's all we're going to do for now. So when we do that, you should see on the inspector, Unity does allow you to take a mono behavior as a serialized field. And here it is, feline, none, feline. This is indicating that so far feline is set to null. But what we can do with that is we can drag the feline game object, which as you might recall has a feline script. We can drag and drop the feline game object into the feline variable. So cool stuff. That lets us do that. If I try to drag in call inside the feline variable, it won't let me do so because the call script is not a feline. But if I try to do the same thing for the cat, remember the cat extends off of feline. If I try to drag in cat into the feline variable, it'll let me do that as well. So that's kind of weird, right? The fact that, you know, feline being able to set inside a feline variable, that makes sense because, you know, the member variable itself is asking, I want a feline variable. Call not being able to be set as in the example above here, that makes sense as well because, you know, call is not a feline. So why is it then that you can drag a cat into the feline variable even though cat technically is not a feline class? And the short and simple answer is that because the cat inherits from feline, cat already shares a lot of similarities with feline. So the compilers allows you to do that. It allows you to cast a cat type into a feline. Another good example right here is actually using the new constructor. So if I were to, you know, basically say void start, and then I say, you know, feline type 1 equals new feline, it'll let me do so. That makes sense. If I say feline type 2 equal new cat, in code it'll still let me do so as well. Practically every language just right off the bat lets you do that. Despite the fact that there's a type mismatch going on right here, because again, a cat is extending off of a feline. So that means that the cat already inherits a lot of the methods, the properties, and the member variables. So because they already share a lot in similarities, the compiler allows you to do this because a lot of assumptions can already be made, and, you know, the conversion from a cat to feline is relatively minimal. This is called casting up. You're casting a cat up to a feline. If you imagine feline as like the parent class, and you're looking at it from like a tree structure where it's going, where all the branches, you know, branches out downwards, then which is how most of the time in programming ancestry is displayed, then you can easily imagine why it's called casting up, because basically you're moving up that heritage tree. Casting down. So let's say that a cat happens to have extra information than feline. So in here, in the cat, we already have this void start, but what we're also going to do is we're going to create a public void make sound function. And what the make sound function will do is it will make the cat go meow. So scary. You know, it's October and all that, so anyways. I don't know where I was going with that. So let's say, for example, I'm going to take those out. Let's say, for example, that you want to say, okay, I want from feline be able to call that function make sound. Go. Because cat has it, why can't feline do it? Well, of course, feline can't do it because it's not defined in there. But if you happen to know that feline actually is a cat, what you can do is you can do a cast down. Casting down, yeah, so if you try to do this, it's not going to run. If you try to switch it to Unity, it's going to say error, type feline does not contain a definition for make sound and no extension method make sound of type feline could be found. Are you missing an assembly reference? You can disregard the assembly reference for now. Again, like I said, if you actually go into the feline code, nowhere in there does it actually have the function name call make sound. So that's what it's complaining about. So how do you fix that? By just casting upwards. So you can do that by simply saying cat equals cat. And then casting is done by putting in a parentheses. And then within that parentheses saying what type you want to cast down to. And then finally follow that up with the variable right here. So right here we're casting feline up to a cat. And then I'm saying cat right here. So when we try to do this, remember, we need to make sure that feline variable has a cat in there. So when we run that, I'm going to clear everything here. What we should see is a meow, which we do. This is not very visible, I noticed. Meow. Meow. Right there. See, it says meow in big letters. So yeah, quick note, there is a quicker shortcut in writing this. You can also just put these in parentheses and replace it that way. That basically achieves the same exact thing. A lot of people prefer to do it this way only because it's shorter code. But essentially this is the same thing as doing this. And it's just putting in parentheses. So this is just as valid of a shortcut as any. Again, here it is. Meow. It's almost like there's a cat in the computer. So far so good. Note that if the variable actually isn't the type that's being casted to, you'll get what's called a runtime error. So we actually have a really easy way of demonstrating this. We can just drag and drop a feline into the feline field. And if we try to run this, we get an invalid cast exception, cannot cast from source type to destination type, which makes sense because what the code is trying to do is it's trying to convert this feline variable, it's trying to cast down to a cat. However, the feline that we fed right here is literally a feline script and not a cat. So it's complaining that it doesn't know what to do with this. It cannot cast this feline into a cat in any way possible, in any way, shape, or form. So that's the reason why that error appears. Whenever you get that sort of error, just to let you know, that's what it means. It means that you're trying to cast something that isn't that at all. All right, let's go back to access, protected access modifier. Since we now have a call script, one thing that's really important to note is, once again, you might recall that any public variables can be called from any location. So if I say feline.public variable equals cool, then it'll let me do that. But if I try to do the same thing for, oh yeah, and I should also mention that private, it will not let me do that either. This was already reviewed back when it was in the first part 1. But protected, interestingly, well, let's just try it first. When you try doing the same thing for protected, you might notice that it acts almost exactly like private var does. So there's the actual difference between how protected variable acts like versus public and private. It is in a weird middle ground of sorts, where protected variables are acts like a public variable in the sense that it's accessible within any of its child classes. However, the moment it walks out of that, out of the child class or parent class, doesn't matter which, as the moment where something else tries to call it, it acts like a private variable where it becomes this inaccessible variable entirely. So that's what protected is. It's just protected within the hierarchy that it's defined in. Any sort of children and the children's of children that the classes that inherit that class that happens to have that member variable. So yep, this is me saying in short, protected variables make variables, methods, properties, classes, and structs accessible to itself and any of its children below its hierarchy. It remains inaccessible, however, to any other scripts. All right, polymorphism. This is a fun topic. So we just talked about inheritance earlier, and inheritance is pretty straightforward for stuff like member variables, because member variables, you declare it. If you try to declare an extra member variable, let's say in cat, we try to define public string, public var. It should complain anyways. Oh, yeah, here it is. Here's the weird squiggly line. According to the squiggly line, oh, this is not very visible. So according to the squiggly line, it says cat public var hides inherited member variable feline public, which is it basically complaining that you shouldn't do that. When we try to do the same thing, or when we try to switch to Unity, you should get yeah, here it is. Warning, public var hides inherited variable feline public var. Use new keyword if your hiding was intentional. Most of the time, if you're getting that warning, chances are very high it is not meant to be. So the compiler will complain at you for that. And long story short, you should follow what the compiler says and probably take that entire thing out. Either take this out entirely, or for whatever reason you can also say, I believe, new right here. Whoops. New right here, and then it'll finally let you off on the hook with that. But long story short, there's not a very good reason why you'd want to do that. Anyways, polymorphism. So methods on the other hand is, and properties for that matter, a slightly more complicated relationship when you talk about inheritance. So in this case, let's start off fairly simple by making it so that both feline and cat happens to have this make sound method. Here we go. I'm just going to copy and paste make sound, and then I'm going to make sure that for feline it's just going to say grrr. Well, how about boo? So you might already notice that cat, which extends off of feline, now has a very similar warning, which says, boink, cat makes sound, hides inherited variable, inherited member, makes feline make sound, use new keyword, blah, blah, blah. Okay, I guess it disappeared. But it's basically the same exact warning as before. And as it turns out, that warning is not without warrant. If you try to run, so here we have call, and then in call, we're going to make it so that it also plays the make sound function. I totally forgot to do that first. Here we go, make sound. So we're going to do some guessing work. I'm going to ask the rest of the room what they think. And for people who already knows the answer, please don't snicker behind the back, but at least let the people who do not know the answer, who may not immediately know the answer to this, let them solve the question, which is, what happens if I drag and drop feline into call and then press the play button? What will I get inside a console? Remember, the function call simply just calls the function make sound in the start function. And then it's checking to see whether it's a feline. The function name is make sound, and in feline, make sound simply makes the console say boo, Well, if it's a cat, it says meow. So in this case, again, I'm going to call drag and drop feline. So what does make sound? What will happen when I press play? Any ideas? Any guesses? Neil?
I'll go for the 50-50 boo.
Boo! So we're going to find out what happens when we play the game.
Okay, what do I win?
Boo! Congratulations, that was a prize. Alright, so what do you think would happen when I drag and drop cat into feline and play the game? It's either boo or meow. And remember, meow was a make sound function defined in cat, and then boo was defined in feline. Where do you put your chips in?
Try red.
Which one?
Meow.
Meow? What does everyone else say? Anyone besides, I'm assuming John and Chris in this case, anyone besides John and Chris want to put their chips in meow or boo? Meow? All right, let's run this. Let's find out if you're right. It's boo. Strange, right? And then I'm going to make this further more complicated. The reason why actually it says boo is because if we actually cast this up, so now it's saying, all right, we want to make sure that feline is a cat first before we call make sound. Now when we run that, it now says meow, yes. So yeah, no, this is really strange, and I'm not going to pretend that it's going to make sense for a lot of people the first time they're seeing this. But the reasoning is actually fairly simple. C# has a permission system. So if you want to override in a child class how a method acts, the parent class itself needs to give permission to the child class that they're allowed to change that method. This is also true of C++ as well. For those that work with Java before, this is completely foreign because I'm not going to lie, Java by default gives every method permission to overwrite. But yeah, as it turns out, both C++ and C# requires you to give permission, requires the parent class to give permission to its child classes to say that you can overwrite this method. So how do we actually do that? It's actually fairly simple. I'm going to skip through this because we already went through that. And then this is me talking about the differences between different programming languages. Again, and I'm saying, however, it is possible to make feline called the make sound. And then also I noted that Java just does this automatically, so you don't need to do this extra step. You just have to add in the feline class, right here, public void make sound. Between public and void, you just need to add in virtual. I do not know why it's called virtual. I'm not going to pretend I know the history behind this. But if you try adding in virtual, what you're actually saying is that you're giving any child classes permission to overwrite this method for their own purposes. So here you might notice there's a little squiggly line. And it still says the same thing. Cat make sound hides inherited variable make sound. But you might notice that something a little different this time around. Hopefully the magnifying glasses doesn't let me grab the right. Okay. You might notice something a little different. When you wrote virtual, it now added this extra note. To make the current member override that implementation, add the override keyword. Otherwise, add the new keyword. So, okay, interesting. Let's actually try following its directions and add an override between public and void. So now we're going to go back to the ultimate call test and again the ultimate pull in the chips. So here it is. I dragged and dropped feline into call. Notice that again I did absolutely nothing. Oh, whoops! I should change this back. Excuse me, sorry. All right, I did have to make one change. I need to remove the casting because that's just going to give me an error. As you might recall, you cannot cast down to cat on a feline variable because a feline is not a cat. Anyways, so here it is. I dragged the feline into call, and now I'm going to play this, and then we're going to take a look at what the output says. You might recall last time it said boo. It still says boo. All right, so that's working as expected. Feline, at least you're consistent. Now we're going to do the same thing for cat. Remember, the new difference is that feline gave permission to cat to override make sound method. So what does it do now instead of this what we were looking at last time? It now says meow. So again, in Java, you don't need to write virtual and override at all. It does it automatically. But in C# you do. When you do so, it allows you to, it gives you child classes permission to overwrite that kind of information. So, I mean, I had to kind of use feline and cat as a poor example of demonstrating, but a couple of more classes that kind of make more sense to add that as an example would be any sort of shapes. So for example, if I were to create, you know, a shape 3D, script, and I'm going to open this. Hopefully it'll let me do that. Okay. So in the slides, you know, I remove polymorphism in action. Why use polymorphism? So in this example, I removed the mono behavior stuff, but polymorphism really is useful for code reusability and to allow child classes to kind of change the behavior within their own instances. So I'm using shape 3D as an example, which as the name implies is basically just public virtual, did I say float? Yep, float volume. And we're going to say by default, this is just going to return 0. And then I'm going to also create another properly just named mass. And I'm going to use the property shortcut. So if you just say get and set, it will automatically generate functions and member variables for you. So this mass now is basically just yet another variable in this case. And then we're also going to add in this density function, which hopefully I got the formula correct. Public float density. And we're only going to create a getter for this. The getter is if volume, is greater than 0, then return mass divided by volume. Hopefully I got this right. Else return 0. Yeah, density is just mass divided by volume, right? Anyways.
Oh, yes.
No, don't worry about it. So in this case, then that kind of allows us to define a couple of different classes that would be really useful. For example, we could create basically a box D. So we can create a box script and a sphere script. So let's open these. Sphere will only take in a radius. Oh, we need to make sure that it's actually extending off of shape 3D. Should be right. And then, you know, a sphere would just take in a radius. So I'm just going to say serialized field. I guess it's serialize. All right, I guess you're acting up today. And then we're going to make that a private float radius. And then we can overwrite the volume. Public override. Incidentally, if you're curious what override looks like for properties, it looks like this. And then I don't actually remember the formula for a sphere. 4/3 math pi 4f divided by 3f, f being floats. This is actually important. Times math.pi. Math.pi is actually supplied by Unity, and it is supposed to be 3.14 whatever. And math.pow, which just stands for power. Radius, oh, yeah, the variable. Radius, oh, come on. Radius, and then 3. So I don't know why it's acting up, so let's kind of close these for now. Oh, I misspelled math. That's supposed to be math F.
So like, why is it that?
Math float. Because not C sharp. I think C sharp standard library has a math, but those are for doubles, and Unity normally expects floats. That's the long and short reasoning behind that. Boxes, we also want to make it into shape 3D. And then we're going to say width, length, height, and then we're going to override volume. Returns width times length times height. Simple stuff. So in this case, it should be fairly simple to understand. I'm overriding the volume. What shenanigans? I guess it doesn't like these. Let me try that again. I apologize for the technical difficulties. Anyways, so Shape 3D has basically this virtual volume that's giving permission for stuff to be overwrote. And then it also has a density property that uses volume information, and then it says mass divided by volume to kind of give you the density. And I said public float here, mass. I'm going to be lazy and instead just say serialize field float private float mass. Excuse my laziness and sudden change. But anyways, so if I do that and I say in the call here, I can add in like a shape 3D. So serialize field, private shape 3D, shape. Why is it complaining? Shape 3D could not be found. Why is shape 3D not able to be found? Well, anyways, we're gonna say debug log shape volume is, and then we can just add in shape.volume, which as you call, you can replace I'm also going to add in a quick float to say mass, shape mass. And we're going to say shape dot, oh. Actually, never mind about this. Shape density is, and then we're going to grab the density property. I think also we can just grab the mass if I just define it here. Public float mass get mass. Whoops. Sorry, I'm going really fast. So, apologies for that. We can start now creating an actual box and a sphere real quick. Box. Sphere really doesn't matter too much that they're parented. Sphere is here. Box is here. Let's say that the box has a mass of 10, a width and a length of 1, and likewise the same story for the sphere with a radius of 1. So if we try to do that and we go to the call and we set, the shape 3D to box as an example, then what the console will let you know a couple of quick information. First off, it says meow because it's going through the cat stuff, but it'll also indicate that the mass is 10. That makes sense. It says the volume is 1. That's because length times width times height is 1, and that was a property that was overwritten by the box itself. But you'll also notice that it properly gave the answer what the density is to 10, which 10, of course, is the mass divided by the volume. If we try to do the same thing, but this time with the sphere, we should get a different answer. Here it is. So the mass is 1, but the volume is 4.18879. It's probably a much longer number than that. And the density is 2.387324. So not only has volume the volume method property, has actually updated itself to accommodate for what the child class actually states the volume should look like, but it also updated density to use the latest volume information as well. So this is just an example of where polymorphism will be useful. It's not just within the class, or not just for being able to use the same method name to create to use all sorts of these simple attributes, but also any sort of function, any sort of methods and functions that are used inside of the parent class, even if they're not redefined in the child class itself, will be updated to use the child class information. Does that make sense? So good practice. When you declare that a method or a property is virtual, it actually does take up resources. So generally speaking, you want to use virtual rather sparingly. But so that said, normally when you want to use a method or a property to be declared as virtual, just ask the question, are the child classes going to overwrite this at all? If they are, then it's a good idea to set it to virtual. Likewise, only use the override on a method if a child class really needs it. If you're trying to define a method that has exactly the same name but is supposed to act like nothing like the parent, quite frankly, it's a much better idea to make a function with a completely different name than what you originally intended on writing, rather than overriding or using the method that has exactly the same name, even if the compiler itself will give you that option. That warning that it gives you where it says like that member is exactly the same name as something that's already declared in the parent, that's a pretty darn good warning that you should be paying attention to. That means you might either want to completely rename that method that you wrote for yourself into a completely different name, or you actually want to overwrite that method. Unfortunately, the circumstances is going to depend on whatever situation that you're actually in. Although I think most of the time, the rather common use case that I've usually experienced is that I usually override whatever the parent declared method is. But if you want to stay on the safe side, renaming it entirely is always the better option, always the safer option. That's going to lead to a lot less bad problems. Override method. An override method can be overridden by a child class. Oh yes, that's right. So if a child class overrides a method, and then another class wants to override that method, it'll let you do that. Feel free to override that method as many times as you like, and anywhere in the hierarchy. The moment it's declared virtual, every single child class is allowed to override it. So just to let you know, that's what this slide is for. If you want to call a method from the parent class, the keyword that you want to use is base. Base acts sort of like a variable from the parent class itself. It's obviously named base because it's like a base class, that kind of stuff. But this is all useful for, let's say, somehow for some reason you want to create a super box. And this will inherit from box, because why not? And then the only thing super cool about super boxes is that it has one more, for some reason, it has one more field. Private float, and we're going to call this extra field. And then, so in this case, to make our code a lot shorter, you can say public override float volume, and then we can say get return base.volume times extra field. So base.volume then would lead directly to, if you can just easily replace that with basically whatever this line is. So that kind of allows us to reuse what the parent class code already has by using the base keyword. Base acts, like I said, acts just like a variable. So if there happens to be other variables within a box, then you can use base dot to get those variables. Same thing for methods, so on and so forth. So if I were to do that, then I say, create empty superbox, and then it's complaining that this has one too many letters. And then we're going to say superbox. It's going to have a massive 1, length, width, height, and then it has an extra field of 2. And then, for some reason, we drag in superbox into shape, and we run that. We are going to get shape density is 0.5 and the volume is 2. Oh, whoops. Yeah, test. So base allows you to basically call or recall some information from the parent class. In Java and C++, I believe it's true for C++ anyways, the keyword is super instead. So you just have to replace base in that code with super, and it will achieve exactly the same thing. There's an example here of a constructor using base. You might recall that there's a shortcut for constructors where if you can use this, it gives you a shortcut to be able to reuse a couple of different constructors that are already declared as a quick shortcut. If you use base, you have to, in constructors, use base if you want to reuse a constructor inside a parent class. And all right, things are moving along. So far, does anyone have any troubles with following along what I've said so far? Is there any questions? Because this is where things unfortunately get really tough.
You can just skip this section.
Okay, yeah, let's skip this section. All right, yes. Pointers. Pointers are fun. Pointers are. If you can figure out what pointers are, then you are a true programmer. So hopefully I can convert all of you to become true programmers by understanding what this next section is about. This is a feature, quote unquote, that classes have. So let's go talk about structs. I know a couple of people earlier that attended the last class, the Intermediate Programming Part 1, were asking a question, so why use structs over classes and vice versa? What's the advantages of using classes over structs, which we already went over. There's a bunch of awesome features that comes with classes, but you know, if using a struct seems like a downgrade to a class, why would you want to use struct at all? And I mentioned earlier that structs are values. They're value types. I'm going to go over what I meant by that. And to clarify then what I meant by value types, I'm also going to say that any instances of classes are pointers. So here's a new jargon I'm throwing around right now. Structs are really useful at preventing a lot of unexpected changes to happen on a member variable within, let's say, a class, or within, let's say, you know, a script that you're making. So we're going to display what I mean by this through experimentation. So yeah, this involves actually creating an entirely new script at all. We're going to create a new script called test bars. And the sole purpose of test bars is to kind of test what happens if we play around with different variables by changing them and copying those values. So here it is. We got test bars. We're going to open it up here in the editor, reload the, yes. And then the only thing we're going to actually really use is the start function here. So here it is. Let's say that we have an integer I1 equals 1. We have an integer I2 equals 2. And just to make sure everyone is paying attention, I'm going to start asking questions. I1, and I2, I2. Also, I kind of mistyped this. I2 is equal to I1. Oh, whoops. I2 is equal to I1. There we go. All right. So what do you expect this output to be? Here is the big money question. I'm going to start calling names. Neil, what do you think I'll get as an output for running this? I'm also going to disable everything else here on purpose. Sorry, give me a couple minutes. Deactivate. And then we're going to create a new object. We're going to throw that up there. We're going to call it test bars. Here we go. So, apologies, Neil. Here's the line of code. Let's follow along. I1 is set to 1. I2 is set to I2. I1, we basically have a debug log of these two lines. What do you expect the output to say? I1 is...
Okay, so it would be 1 plus I1.
Right, so it'll say, this one will say I1 is I1, and then what will say for I2 right here, this line?
I1 plus I2.
Well, let's see if what you say is correct. Not quite. It'll say I1 colon 1 and then I2 colon 1. This actually makes sense because we're literally taking the value I1 and we're copying it over to the variable I2. So far that makes sense. We're going to add in one more line. We're going to say I2 is equal to 2. And then we're going to play that. So what do you think will happen this time? It's going to give you 4 lines. The first 2 lines are exactly the same. Will it say I1 is 1? Anyone? Yep, and then what will I2 say? Let's find out. There's inconsistent lines according to my compiler. Okay, so the first 2 lines, exactly the same thing as before. I1 equals 1, I1 equals 2. And then here it says I1 equals 1 and I2 equals 2. So yes, those are all working as expected. We might as well actually just use equal signs. So far that makes sense. Now let's try doing the same thing except this time with a struct. So I'm going to define a quick struct right here. As you can see, I'm just going to be lazy. I'm not going to even bother naming what the struct actually is. It's going to have a public, which is always a bad practice. Do not ever make public public member variables, public int I. Yeah. And so we're going to change this. It's going to be S1, S2, and actually, yeah, there is one more. I did actually want to create a constructor in here. I new I equals new I, which, as you know, if I call this constructor with a parameter, that means that it sets its member variable immediately to that value. So S1, I'm going to say equals new S1, and then S2 is just going to be equal to S1. And likewise, we're going to replace these as follows. And then here in S2, I'm going to replace that with .1. Oh, these are also supposed to get .1 as well. .I, excuse me. So I'm going to skip this part for a minute. And then let's just say, what do you think would happen if I run these 2 lines? What will it say? We started by declaring that S1's member variable through this constructor right here is set to 1. So at the very least, we know that S1.I is going to be 1. What will S2 say? Anyone? 1. Cool. So far, yep, that's correct. Now, a small difference is that I'm going to run the line where it says S2.I. I'm changing the member variable I into 2 on the S2 variable right here. And then it's just going to run exactly the same code for debug again. Any ideas what this will say? Same. Yep, 1 and 2. So S1 remains completely unchanged, the member variable, and S2, the member variable, has changed because this line has ran. You might recall that this is exactly the same behavior as you would see inside the integer. So, you know, if I were to copy and paste this, except with int, maybe I shouldn't have deleted that last time. Bah humbug. New, no, we don't need this. Then I, there we go. So you might recall that this behavior looks exactly like the integer. So with integers I1, both of these are set to 1, and then the first one was set to 1, and then the second line, all I did was change the variable I2 to 2, so that gave you 2 as I2, but I1 remained completely unchanged. Same thing for structs. So now, classes. I mentioned earlier classes are pointers. And it seems like Chris already has a pretty good idea of what's going to happen next after this. But I'm going to still go through the motions anyways. So here it is, class. We're going to call this C because, again, I'm being lazy. This is exactly the same code as before. And I'm going to copy this, except replace all the C's, S's with C's. Oops. C. By the way, if you're curious, no structs cannot inherit from classes, and likewise classes cannot inherit from structs. There's no possible way of that happening. So who knows what will happen with C? The first two lines, of course, will say 1. So far, that's all been consistent. But what does the last two lines will say? I mentioned earlier, Chris seemed to already know what the answer is going to be, but what were you thinking?
I'm thinking they both change to 2.
Anyone else think they won't change to 2? Let's duke it out. All right, so here are the integers, 1, 1, 1, 2. Good stuff. Here are the structs, 1, 1, and 1, 2. Good stuff. And then with the classes, C1 is 1 and C2 is 1. So far that looks good, but wait, C1 is 2 and C2 is 2. Strange, right? That's not what you would have expected given all the stuff that you learned how integers work, and basically strings and floats and all that sort of stuff. All these work like you would expect. Structs works as you would expect. Why is it that classes doesn't work as you would expect? And as you would expect, like this is the key line. These two lines are the key lines right here that causes these problems. So this is the mystery of pointers, and it's not fun trying to wrap your mind around this, but it's fairly simple to understand. So here are the results that I was just talking about earlier. And yeah, you can see me putting a bunch of question marks there because this, for the longest time, didn't make a whole lot of sense to me either. It's actually not that hard to understand. Good news. Pointers are basically a digital equivalent of a physical mail address. A mailing address is useful for finding a house. Once there, one can either store or take content out from that shelter. If your friend copies the address, however, they only copy the number and the street name of that address. You both now hold a reference to the same house, but your friend who copied over that address did not create an entire new duplicate of that house at all. So what's actually going on in this case is the moment you say C2 is equal to C1, what you said was C2, I want you to hold the address to the memory location that C1 points to, which means that they both have the mail address to that house. But the moment I say C2 I equals 2, what it's going on is that, C2 is like, all right, now I'm going to go into the house go look for the I, and then change that up to now hold the number 2. So now when C1 looks through its I, because it's both C2 and C1 are looking at the same exact house, it also sees number 2, because the line earlier says, well, change it to 2. C# and Java basically hides the fact that instances of classes, which from here on out I'm going to call objects, are pointers. In reality, objects only store addresses to memory locations that the variable data is actually being stored in. The example on the right is C++. You might notice that when you're declaring, so you're saying, see how it says right here, C star C1 equals new C1. C++ is pretty darn explicit. You have to pull a star in to actually declare it to be a pointer. So if you're coming from C++, these look a lot more familiar and easier to understand because, quite frankly, C++ requires you to understand what the heck pointers are, whereas C# and Java kind of makes it look like it's just any other variable. I'm not going to go too far into the details here. I would highly recommend checking online any C++ manuals explaining how pointers work in those languages. Looking back, when the line new was used, it was allocating a new memory space to store C1's content. When C2 was set to C1, however, only the address to C1's content was copied. There you go. So both C1 and C2 hold the address to the same object, and thus any changes that you make to C1 or C2, or any changes that you make it to C2's member variables will also affect C1's member variables as well. In other words, they actually represent the same thing. Benefit of pointers. Well, it's basically Google Docs, right? In Google Docs, you can have multiple people edit the same document. Same thing with pointers. Pointers allow multiple different entities, whether it be methods, functions, threads, whatever, edit the same member variable at the same time. They also tend to save memory by encouraging the programmer to reuse the same memory location multiple times rather than constantly creating new sets of duplicates of memory locations. Yes, question.
Well, in specific to this language, what will be the advantage of using the pointer address instead of just a regular address?
C#,
Yes.
C++.
Well, I know C++. With pointer, you're allowed to take the address of a function and pass it as a parameter, or use it in pass-by references. Is that similarly done in C#?
Oh, so wait. So in functions, you mean you can pass things via references, is what you're asking. That is advanced material stuff. But if you're curious about reference, if you throw in a reference of an object, which is a pointer, of course, if you throw a reference to an object, it'll act like the object as if normal. So oftentimes, there's actually really no good reason why you'd want to throw an object with a reference parameter. So C++, there's a good reason, but C# there isn't. Because quite frankly, you would, for the most part, achieve the same exact effect, unless for whatever reason you want to say new within that method itself, which is an incredibly rare scenario that I don't usually recommend doing from the first place. So benefits of pointers. It's also worth noting that for pointers, I really didn't bother to describe what's going on with these parameters inside functions at all. What's actually going on when you call a function and putting in any sort of values as part of its parameters is it's actually creating a copy of those parameters and then throwing it into the method and going through the method, whatever the steps the function / method states. So that means that if you try to throw in, like, say, an integer in there without adding any extra information outside of int I, as an example, then even if you make changes within that method itself, you're actually not going to see any changes made on the variable I. Here's a quick demonstration of what's going on. So if I had this function that increments I, but if I run function I on I and then try to say debug.log I, the value is not going to change whatsoever. It's going to print 0 right here. It's going to print 0 right here as well. Because, again, what's actually happening inside functions is it actually creates a copy of that variable. However, if you replace this with objects, objects simply copies over the address of that location. So if you try to do the same thing here, changing by the I member variable, you're going to notice that here here we declared C starting off with a member variable of 0. If we say print 0, it's going to print that. We're going to say if we run that function, it increments that member variable and then gives you 1 because this C parameter right here and the C that we just fed into that, or C that we fed into that function, point to the same memory location. So if you want to make any changes within a function itself or a method or a property, then you'll want to use objects as well. There's the only other way to change, what the value. There are actually a couple of shortcuts if you want to change what the value of things are. But for the time being, this is the easiest way of doing it. The only other good method is to return changes. So for return an integer once you change whatever the parameter says, and then actually reset that integer variable. For now, a lot of what I'm talking about, a lot of what you want to do, you can just achieve through those workarounds. So okay, you'll be asking a question. All right, that pointers are cool and all, but how can I actually really truly duplicate objects? So that this set of line right here where it says C1 equals, or C2 equals C1, don't end up pointing at the same exact location. Well, sorry, you had to make a function. You had to say public, let's say C, I'm going to use the term clone, and then it's just going to be return new CI. And then you simply have to replace that with clone. And you'll have now, and now when I run this, here we go, you'll have the same exact, you'll have the same exact 3 lines of code here to the people who are just reading the stream right here. See, it now says C1, 1, 1, 2, so now it's finally acting like any other variable. So ultimately then, the only way to really achieve that here is just to create an entirely new method. There's unfortunately no other way of doing so. Quite frankly, in my opinion, for good reasons. But yeah, just to let you know, this is the only way to do it in C#, in Java, and in C++. It's consistent amongst all 3 of those languages. Deal with it is the quote I have for that. Good practices, since it uses less memory in most cases, it is highly, highly, highly preferable to use classes over structs in the grand majority of the scenario. Not only that, but classes gives you this access to a ton of functionality and features that structs simply do not have. It's also more relatively easy to use. For example, I mentioned earlier that structs you're not allowed to have default constructors, any constructors without any arguments, but you are allowed to in classes. Likewise, in classes, if you want to declare a member variable with a starting value, you can do that. It's really as simple as just saying equals 1 under the member variable declaration. If you try to do the same thing for struct, it's going to actually complain at you. See that little red squiggly line? That's it saying you can't do that for structs. So with all that in mind, you know, most grand majority of the time, you're going to want to use classes as much as possible. However, there are good reasons why you want to use structs. I mentioned earlier that structs are really useful for any member variables that is designed to change incredibly frequently. You might notice, for example, Unity chose that vector3 should be a struct. If you try looking over documentation on vector3, for example, it'll say it's a struct. That's because a lot of the functions that is involved with it, like let's say for example transform.position. Transform of course is a class, but it has a property named position, and position is a vector3. Position changes a lot because it determines where the location of that game object is going to be, and seeing that, you know, it is going to change a lot, imagine if that was a pointer. You can see that a lot of horrible things could possibly happen if they're sharing addresses. So in this case, they chose wisely to use a struct instead, because that confirms that that position is the transform.position variable will never be shared with anyone else. It will be its own separate variable. So in those it's fairly rare in my opinion, but in anything that like really changes at a super rapid rate and needs to be grouped group member variable information, that's when structs are really useful. Let's see, what are we looking for time? We are looking at 8:26. Okay, we have 30 more minutes. I'm going to use up that rest of the 30 more minutes for adding just this real quick abstract class. So let me take a drink real quick. So you might notice earlier that I gave an example called shape3D. So let's switch to that. And in shape3D, we gave a default behavior to volume, which is it returns 0. By all means, this is a terrible default. Like, why would you want something that always returns 0, right? There's really no good reason why. So, is there a way, let's say, in programming here, is there a way that instead of saying return 0 or give even a default value at all, we just say, hey, this function, it doesn't do anything? And the answer is yes, you can do that by using a term called abstract. If a parent class has a method or property that doesn't have a good default behavior, one can set that method to abstract, indicating that 1, that method or property has no behavior at all, and 2, the child class must override that method or property. So let's do that as a quick example. Abstract is super simple. You just simply replace virtual with abstract, and then see how it says get return stuff here. It's not expecting anything to be defined in get, so you just can put semicolon and call that a day. And that should be it, actually. Okay, and then it's complaining about one last thing. So you might notice that if you try to make an abstract property or method, as it may be, it's going to say the same thing. It's going to say right here, enhance. It's going to say shape3d.volume.get is abstract, but is contained in a non-abstract class shape3d. What does that mean? Well, as it turns out, abstract methods can only be defined in abstract classes. So how do you make this shape3d into an abstract class? Simple. Abstract. Done. Hooray! So now if we run this, and I'm going to disable this, deactivate the original game object, enable call, and run this. Yay! So the same exact code that we had earlier works exactly the same as before. So really abstract didn't do a whole lot other than that it allowed me to remove a whole lot of cruft under volume, because return 0 was not a very useful behavior from the first place. So here, again, this is the way I improved shape3d. It's basically shape3d says volume has to be overwritten. Extending abstract classes is simple as just adding an override. So abstract acts just like virtual, except in and of itself it has no definition. It's worth noting that for method, the idea is really simple. Writing abstract methods is equally as simple. Instead of the property where you had to write in an extra bracket and then finally a get, or maybe even a set if I needed to, instead of writing all those in, you just have to put in, instead of any colon, curly brackets at all, you just put in a semicolon and call that a day. So far makes sense? Objects of abstract class. Since an abstract class has methods or properties that are not defined, you cannot construct abstract classes. So if I were to, for example, go back to my call method, and here it says shape 3D. If for whatever reason I say no, shape has to equal new shape 3D, it's going to complain. It's going to say you can't do that because that is an abstract class, and abstract classes are not allowed to construct new instances. Just one of the limitations of abstract classes. And it does make sense because, as I mentioned earlier, if you actually constructed an abstract class, then you called volume, well, what does volume now do? So it's saying you can't do that because volume is not yet defined. However, you can say, instead of this, you can say box. Oh, I accidentally shrunk the text. Whoops. You can say box, and it will accept that instance. The reason why it accepts box in this case is because box inherits shape 3D. So basically, it's casting down box into a shape 3D. So that's completely allowed. And likewise, you get to kind of treat, if you have like a method or if you're using this member variable, like right here, shape 3D shape, it automatically casts down to that value, and then you can use volume, the property volume or the property density like you normally would with anything else. Ironically, in abstract classes, you can define constructors. You just can't use it. It's a little weird, but the reason why abstract classes allows you to define constructors, which let's actually define one right here. Let's go in shape 3D, and I can, well, I mean, this is Unity, so it's going to actually complain at me, but you can actually define constructors, and it's actually not going to complain. Notice it's not complaining right now. Now, Unity will complain because Unity doesn't like it when you do that for model behavior, but just to let you know, you can actually do that. You can define constructors inside abstract classes, even though you cannot actually create new abstract classes directly. The reason why is because anytime you have any read-only variables, read-only int ID, then this is the only way to do so. If you try to, especially if this is a private read-only, right? If you try to do that, if you try to go through the child classes and replace this, so let's get a super box, and then maybe box public box, I think it will complain. See, yes, it's complaining. This is the reason this must have, oh. Okay, it's not complaining, never mind. But yeah, the reason why you can actually define constructors inside abstract classes is because it allows you to actually define read-only variables. Child of abstract classes can also be abstract. Just real quick, there's nothing preventing that. Feel free to use abstract wherever in the hierarchy. Good practices. Using abstract classes is great if you want to force children of that class to define specific methods and or properties. C# has other methods for, let's say you want to create a class that contains only functions. Abstract classes for Java is useful for that. For C#, there's a different alternative for it, so it's often not recommended to use abstract for that. There's, like I said, a completely different method for using that. But yeah, basically that's the purpose of abstract. And that's it. Any questions from the materials that we covered so far? This is the grand majority of the information that I think is necessary to get started on developing for the Unity 3D game engine. So at this point, I will say that if all of what you read here and you've listened to made sense, then you're good to go with starting writing scripts for Unity 3D. I will say, however, there are some really useful stuff that I could talk about later for advanced programming. So I guess later on we can add in a quick lesson for advanced programming part 1 and 2, because even that is a dense topic. There's a lot of other random features I haven't really had the time to cover that at the grand scheme of things I consider are not very important to talk about. The only one that actually genuinely is important to talk about that I haven't covered is interfaces. And I didn't cover that just because it's actually a little more complicated than I expect, and I didn't think that I would have much time to talk about it. But frankly, that's about the only one that makes me go like, oh, if you didn't know about that, you might have trouble in the future. But interfaces are fairly simple to understand once you understand how abstract works. They're actually very similar, but it has some wacky restrictions, and it's a little strange how you use them. But other than that, like I said, if you think this was all useful, then we'll add in advanced programming as the next set of lessons to go along with this very long and dense series of topics about programming. But like I said, if you've gotten up to this point and you're able to follow everything that I was teaching and I was saying, then at this point, I think you're a good enough programmer to get started and face the world of what it's like to program for Unity 3D, for most other game engines. All right. If there's no other questions, then I'll close the stream, and I guess we'll move on.
Thanks very much.
Yeah, no problem.